Welcome to qnawire.
Okay, so first we need to determine the spring constant. Spring constant is equal to F1 over X. And we know at the beginning there's only gravity of the block was applying to the spring. And the distance was stretched by about 0.070 meters. So therefore the spring constant is equal to mg over x, which is equal to 0.10 kilogram times 9.8 meter per second square over 0.070 meter, which will give us the spring constant is about 14 Newton per meter. And here, this is the free body diagram I drew for this question. So there's a restoring force that was pointing upward when we pull the spring in the downward position. So in the downward position, there should be gravity and the force that we apply, which is F2 here. So therefore, F2 is equal to restoring force minus mg. And when the restoring force is 3 Newton, mg is equal to 0.1 kilograms times 9.8 meter per second square, which will give us the force that we apply is 2.02 Newton. So therefore, we'll stretch a certain amount of distance here, okay, which is the place or the position that the block will start bouncing while I let the block go. So we have F2 over K here, which is 2.02 Newton over 14 Newton per meter, which will give us 0.144 meter. So the block will start somewhere which is below the equilibrium position, okay? So we start at 0.14 meter below the equilibrium position while I let it go. And for the next question, it was asking us the work during the stretching process. So the work during this stretch process should be equal to 1/2 times k and then times x2 squared, because we stretch this amount of distance, okay? So therefore, the work done should be equal to 0.145 Joule. And question C was asking us the total energy of a system. The total energy of a system is equal to 1/2 k squared. And m2 here should be the initial stretch distance, which is when the gravity of the block applied to the spring, and then plus the distance we stretch, which is x2 here. So therefore, we have U is equal to 1/2 k times x1 plus x2 squared, which is equal to 1/2 times 14 Newton per meter, and then times 0.070 meter plus 0.14 meter squared, which is equal to 0.32 Joule. So the total energy is equal to 0.32 Joule. And for question D, well, so remember we stretch about 0.144 meter. So the distance of a block that will be travel after I release it should be 2 times the distance I stretch, okay? Because it will bounce up and down like an oscillation, okay? So therefore it's 2 times x2, which is 2 times 0.144 meter, which is 0.288 meter. And for the last question, this is the energy bar charts I drew for this question. So the energy will be reduced as the time goes, okay? So in the question, we're saying that the vibrations last for 50 cycles, okay? And we know there's air resistance involved during this process, so which means that there should be some energy loss due to the air resistance. So as time goes, the energy will be reduced. So on the left, this is the energy at cycle 1, and then on the right, this is the energy at cycle 25. And these are the answers for this question.